Hi everyone, welcome to our another episode of our Tech Talk. Today we are going to be talking about database. Database is such a fundamental topic in IT. Anything you want to do, any project, you would very likely come across databases. It is one of the essential things to know about. Even if you don't want to be a database expert, you should still have a foundational understanding of database, what it can do, what kind of things you can achieve with it, and at what point of your project you might need to utilize the help of a database. So we thought that it would be a really good topic for us to cover. Let's just dive right in.
Yes, Rinat, thank you so much. I think the introduction was good and it is quite relevant. And even for people who just want to do hobby projects, I think managing data is quite useful. And I think people are already managing data in some way, which they don't realize, and that's using Excel sheets or Google Sheets. So people use Excel sheets quite a lot, and it has data in it. It has rows, it has columns, and they create tables in it, and they can create graphs out of it. They can do calculations. So suppose they put a value in a cell, they can then put another value in another cell and then calculate the sum or the count, etc. So people in essence are actually using database without even them realizing that they are actually dealing with a database. But then there is a fundamental difference why we have Excel sheets and databases, and that's what we are going to talk about. So I
Yeah,
want to ask you, what's your
yeah.
understanding from your experience?
Yeah, so for me, as you know, my experience in IT is a little bit limited, even less than 5 years. So I have learned various topics or aspects of IT. I've kind of self-taught myself, or whenever I came across something, I kind of learned how do you do it. So database is one of those things that I never had a formal course on, but I've come across it so often that I've kind of built up some knowledge on database. But when I first came across database, I had no idea what I'm doing, and so I thought, okay, what does the name say? It's a database, so obviously it has something to do with data. It's a storage system of data,
Yes.
and how do you store data? Now, if you want to store data, then you want to basically have a good way to address them so you can recall the data very easily. So that has to be a primary feature to have a database. You have to be able to find the exact data you're looking for, because you obviously have to store massive amounts of data. How do you find the needle in a haystack in a very easy way, or very quick, efficient way? That would be the defining characteristic of a database. So I thought,
True.
naturally, whenever you want to store data, whether it be any kind of data, first of all, it has to be, there are various kinds of data. There are numbers, there are strings, there are images. There could be so many different varieties of data. So something that can handle all of these types, and then can have an easy way or an efficient way to recall a specific set of data based on some rules or condition. So anything, any system that allows you to do that, I would call that a database.
It's
For
true.
example, as you
It's
mentioned,
yeah.
yeah, as you mentioned, Excel. In Excel, you can store various data points, whether it be numbers, whether it be text, and it has a very easy to understand addressing system. It has a row and column value. With that row and column value, you can store any large number of data. But if you know the address, the column letter and row number, then you can easily get to exact pinpoint the exact cell number that you're looking for. So yeah, that in that way, Excel is a good database in that way for general use. But then there are also specialized databases which are a lot more powerful, and I'm sure we're gonna get into a little bit more in depth on those. But yeah, I mean, that's my understanding of database, and it's quite simplistic, and I kind of built it up from my common sense. But yeah, I think that's a good way to understand database.
Yeah, I think you have covered the most fundamentals of a database.
Mm-hmm.
It should have data in it firstly, and then we should be able to retrieve the data for whatever purposes we want. So we always start with Excel sheet whenever we want to do some calculations. So the reason we store data in a structure is so that it's easy for us to read it, easy for us to retrieve it, and then perform some calculations on it. So that's the reason. But the database itself has data in it, and data can be multiple types, which again you covered: videos, files, audio files, text files, just rows and columns of particular information, etc. So data itself is of different types, and I think it's important to understand the different types of data first before we actually understand why we have different databases, because there is not one type of database, there are multiple types of database, including Excel sheets. So, in order for us to understand what a database is, from what I've read and what I've seen, is you have structured data and unstructured data, and then you have semi-structured data. Structured data is
Right.
something that can be put into rows and columns. Each row is having information for one particular type. So say you have a school, and school have a lot of students, and those students are in a classroom, and they have particular subjects, and they score marks in those subjects. Now I can have a table where I have the students against the classes. I can have the students against the subjects. I can have the subjects against the classes. I can have students with the marks, etc. So I can have multiple relations of the same data
Mm-hmm.
with multiple things. In Excel, it's very difficult because you can either put class or student, or student or subjects, or subjects or marks. You cannot put three, so it's basically two dimensional, and
Yes.
that's the problem. So when you have such type of data, it's structured because we still have a structure. So we know that we'll have schools. The schools will have students. The students will have classes to go to, say first, second, third, fourth, and then they have subjects and they'll score marks. So we already know the type of data, so it's structured data. And then we talk about unstructured data. So suppose the content of an email. How do you structure the content of an email? You cannot categorize it. You can just say it's subject, or say body of an email. But the content itself is unstructured. You cannot put it in any, you cannot define it. A photo,
Yes.
a video. How do you define a photo, a video, and put it in a database? So that's unstructured data. And finally, we have semi-structured. Semi-structured is data about data, or metadata.
Right. Yeah.
So the unstructured content, say in an email, is the body of the email, but the body of the email has a tag, say body. The subject of the email will have some content in it, but it's called subject, and then you have email address, etc. So you can still identify that it's an email based on who's the sender, who's the receiver, what's the subject, what's the body. So those are the different metadata, and that's how you have. So now you have all this data. So I'll ask you a question. Okay, you told me that we have a database, Excel sheets, and etc. So we can store two-dimensional data, maybe in, we can even store three-dimensional data, but Excel normally goes for two-dimensional data. So from your basic knowledge, how do you then extrapolate that same thing into three dimensions or four dimensions or multi-dimensions for structured data? Then we
So,
can talk about unstructured.
of course. So, I mean, from what I understand, is obviously when you move from two-dimensional to three-dimensional or multi-dimensional data, you have to have the relation of different
Yes,
items very well defined.
yes,
So you could in SQL databases you have something called the key in each of the table. So
yes,
that key could be matched with another table's key. So that way those two tables are matched up together from one column which is the same in both of them.
yes, exactly.
So that's how you could. That's how I could. You could have it three-dimensional, and then you don't have. There is no limit. I mean, you could have four dimensions, five dimensions.
Exactly.
How however many relations of each of the data points you have, and you can create various graphs and various insights, which are going to be not easy to visualize in a say for example 2D pie chart or a 2D bar graph, but you could have it like a 3D cubic visualization of a data, which will give you a much more insight on how each of these data points are related. This is actually very quickly going on to another topic, which I am also very interested about. Is called fuzzy logic, and there is a topic which kind of helps you understand and visualize data in a way that is more humane, like more not humane, but more human. So yeah, I mean there are many ways to sort of use and use data with some of the things that you said, like multidimensional data. So yeah, I mean whenever you have a number of more than one table, more than just rows and columns, but then each column is related to another table's rows and stuff like that. That way you can have like a multidimensional data structure.
I think you've nailed it. I think yes, that's why it's called relational database. So,
Right.
relational information. So structured data in Excel, the problem is you can have two-dimensional data, you can have multi-dimensions, but there is no way to relate them. So you can have class with subjects, class with student names, class subjects with marks, students with marks in different subjects. So you can have maybe two or three dimensions at the max. But apart from that, there is no other way. So in order for us to have multiple options and multiple relations, it's important for us to define those relationships, and that's how we define. We pick up one column which is common, say the student name. So the student name would be common for the class, the subject, the marks, the school which the student belongs to. So that can be a fixed key in all the different tables, and then using the student key we can actually get information about their marks, their subjects, the classroom and the school. So exactly, so that's why it's called a relational database.
So tell me one thing. I mean, this is something I kind of always wondered about. Yeah, I mean, we could be all fancy and have multidimensional data, etc. But what is stopping me to sort of make convert all of these different dimensions into a big table? Because there is always a relational key, right? So students with marks, and then marks with subjects. So you have one table
So
where
you
the
need
key
to
is
have
student.
different tables. So see that as you're describing the problem, you can see that it's difficult to do that in Excel sheet, right? If I have
Yeah, but if
students in
I
one column and then I put marks, then and say I put classroom, but then how do I put subjects and how do I put school name?
right. So the school name is gonna be same for a
Say
lot of the
50
students.
students, 50 students,
Okay.
and
But
then
even then, I could have like a really big table which has all the data
yes,
with
but a
some
table is
duplicate.
made of a row and a column. That's it. So how do you
Ah, I
fit
see.
all
So
the things in the rows and columns? That's the
so if
challenge.
you have multiple columns, why can't I
So
have multiple?
so the multiple columns. So say you have student name and then you have
Mm-hmm.
subjects and then you have classrooms. But now one student can be say for a one class, and then you have 50 students, 20 are from one class, 20 are from different classes, and you can actually have data like that, but then there is no easy way to filter it out.
This is just so you don't have to bring out all the data all the time. Because if you made a massive table with like 20 columns, then
True,
every time you query something, you have to have a lot of memory.
true.
And if a company like Facebook, they will have a really massive
Yes, agreed,
number of
agreed.
columns.
Yeah.
So that is one reason
That I
from
think that is the I think the best reason from what I can imagine, because you're right. We can have different columns and each column can have different types of information about the same student, and then we can extrapolate it. But I think it's easier to manage them. But it's not just student records, right? So this is just one student with all the attributes related to that student. But now you have schools and you have schools with multiple students. How do you put that data? Maybe you can have a school name as a column, and then you can get the data for each school with the children and the subjects and the marks. But then again, it's very simple. So suppose you have other types of information and you want to combine those information and see how it behaves. So all that I think is more difficult to do in an Excel than with a
yeah.
database.
And also another reason I can think of is how when we are gathering the data. A lot of the
Yes,
times we're not gathering all the data at the same time. We're probably when we're just gathering this student marks in one school, then we're just gathering that piece of data. So if we create a massive table with 50 columns with school name, subject, and all of this, then when we're gathering the data, it would be difficult to sort of capture them because there's so many columns,
which might be empty.
yeah, yeah, which will remain empty, and that's not really ideal. But you're taking up all the memory when you're doing that.
Exactly.
So yeah, there is there is benefit in data capturing, benefit in data retrieving, benefit in data visualization, because when you're visualizing, you're trying to find relation between two columns or three
Yes.
columns. You're not trying to find relation between 50 columns.
But you
So
have
when you're
already
trying to,
identified the relation when you have identified the key. So when you identify the
yeah,
key, that's when you define the relation.
yeah, but say for example, we want to see how, you know if there is a relation between if if there is a relation between the height of the student and how good they are in maths. In that
Yes.
maybe there, yeah. So say
There
for
could be,
example, then in
yes.
that case, yeah, so in that, I mean, we could have one column with the student height and one column with their maths result. But if we have 50 columns with all of their other details, that are not what we're trying to visualize now, which are not relevant to what our current focused research is all about, then we're kind of, getting confused with all the other data, which is kind of
Yes.
distracting
So
from the.
you can have one data just for subjects, one data just for marks or subjects and marks, and one data for classrooms, one data for school, one data for student names, etc. And that way it's easy to manage the data and easy to scale it up. And then you can combine the data later using the key. So if the
Yeah,
student name is common for everything, then you just query the data what you need and then you combine it. But I think
yeah.
we are going too much in depth. I think let's again come back to structured data. So we know a data which has a structure, data which is unstructured, and data which is semi-structured. So in
Yeah.
order for us to have unstructured data, um, what are the challenges and how do we actually query unstructured data? So suppose you have videos and photos. How do you query videos and photos? And how do you store them? So imagine if you have YouTube, you have to run YouTube. So you have lots of videos uploaded by people. How do you actually store those videos? Do you store them in a relational database or do they use something else?
That's a good point because a video has a lot of other related data as
Metadata.
well, like how many
Yes.
people commented, how many likes that it has, and other analytics which are going in the background, like what is the topic and how many, whether it will be
But that's
suggested.
Rina, that's just after once the video is uploaded. So what happens before the video is uploaded? You still have data related to the video, like what is the codec, what is the resolution,
Ah,
what is the
yes.
sound, how many frames per second, uh, when was it published, who uploaded it, etc., etc. So those type of information is still there, and that's a lot of data. And imagine so many like hours of video are uploaded every second on YouTube. So in order to store that and then retrieve it, so whenever you type something, it queries all the types of data and then sends it back to you.
Yeah.
So that's a huge challenge. So how would they do something like that? Any ideas?
No, no. I mean, this is like such a massive scale. It's happening that I have not actually come across that in my experiences.
So normally what we have seen, they query. They query using API. They call API and they say the REST APIs, and they query the data, and they already have indexes. So you know how Google does. So uh, co- uh,
Web crawling.
Google queries, sorry, crawls the entire web. So after crawling the entire web, it has a big database of URLs. Now the thing is, it has to categorize all the URLs. So the URLs are related to shopping, URLs related to social media, URLs related
Mm-hmm.
to maps, URLs related to travel, food, etc., etc., job sites. So it has to now classify all that. and then it has to create an index. So okay, so I'm searching for, say, an actor, say Tom Hanks or Tom Cruise. So I search for Tom Cruise. Tom Cruise is an actor. So I want to give the information back to the customer as to, okay, I'm searching for Tom Cruise. Tom Cruise is an actor, so I have to look for only acting websites or websites where the actor might have given interviews. So magazines. So I create an index of, okay, all acting websites. So I'll just search through that. So I have an index of, okay, acting websites, and I search only through that. I don't search the entire database, and that's
Right.
where you
Yeah.
have index. So database has indexes. So when you have large amounts of data, you create an index. Okay, so like in a book you have an index. Okay, if this is the word, which page it is? If that is the word, which page does it belong to, or which chapter? So you can quickly go to that word exactly in the book, and that's where indexes are helpful. And similarly, you have indexes for database. So when you have a database with millions and billions of rows, you need to have an index to easily search the data. And I'm
Yes.
guessing this is what would happen for YouTube, Facebook, and other things. Now, Facebook is again very interesting because how do you store data for people liking comments, people putting a comment, liking, disliking, unfollowing, following, etc. on Facebook. Now, imagine the different kind of relationships, right? So, so suppose I have a Facebook profile on Facebook, and my whole thing, like my name, my address, my date of birth, my profile picture is in one, say, um, a cell, for
Yeah.
example, and then you have your profile with your name, date of birth, etc., address, and then you have
Mhm.
another cell. And now my profile likes something that you post, and my profile on your profile likes something that I post. And we have to capture that relation. Now imagine
Yes.
you have 20 friends, I have 20 friends, and those 20 friends who are your friends because you have liked my post can see my post in your feed.
Yeah. Yeah.
So now how do you manage all that? So that's where graph databases come.
Right. Okay.
So graph databases have node. So I am a node, you are a node, and there are multiple nodes. And then there are
Right.
relationships between the nodes, friends of friends, followers, first line followers, second line followers. In LinkedIn you have first line, second line, third line.
Yes.
People you're connected to directly, people you're connected to directly, indirectly through someone else, or indirectly through someone else and someone else. And that's where you have nodes, and then you have the connections, and that's where
That
graph
is so
databases come in.
interesting. That is very interesting. Yeah, I actually want to know more about this graph. Um,
I mean,
deployment
in
system.
principle, this is what it is, right? If Facebook has to store
Uh-huh.
all this information and then try to figure out how to manage who has liked what, who has commented what, when have they liked it, what have they liked, and then the relationship between each person, they have to come up with something new. They cannot have something in a table with rows and columns.
Yeah, yeah, that
And
would be too difficult to
it's too
manage.
difficult. So this is again a part of unstructured data. You can say it's a structured data, but it's something that you cannot query like a normal database. So
Yeah.
so we have talked about data. We have talked about database which stores data. And the reason we have
Mhm.
database and not Excel is because you can have multiple relationships, and you can scale different types of information in it, have multiple tables, columns, fields, and then you can query them. But uh, we have unstructured data which you cannot query like just like that. You will have to have something else to query, etc. And then we also have something which we can store in a flat file. So have you heard of CSV?
Of course, yes. It's
CSV
one
is
of the
comma separated value, right?
values. Yeah.
So and there are basically different types of files which are called flat files. Flat files are very simple. They just have rows and columns with a heading. That's it. It's nothing else. It's a simple text file. But
Mm.
each row has information separated by a comma, and every line is a new row, again separated by a comma. So that's a
Uh-huh.
CSV. But instead of a comma, you can use a tab. So it becomes
Yeah.
tab separated value TSV. You can use a
Yeah.
space, you can use a colon, you can
Yeah.
use a hyphen, etc. So anything that you separate, it becomes that. So, but the most popular is comma. So you
Mm-hmm.
separate the file. So now imagine you can actually store the data in a simple text file. You don't even need Excel.
Yeah.
So
Yeah.
that's flat file database.
Right. Right. Okay.
So this
Cool.
is
I
again
mean,
very
I've
interesting.
dealt with the CSV so many times, but I never knew that it's called flat file. It's
It's called a flat file and it's one of the flat files. So like
right.
CSV, TSV, and there are other delimiters which limit, which say, okay, this is the end of one type of data, this is the beginning of the other type of data. And this is the end
Right.
of
Right.
one line, this is the beginning of another line. And that's how you separate the values. And you can store it in a text file. And databases that way is it's quite lightweight, flexible. But one thing that we have not covered is SQL. Every time we talk about a database, we come up with SQL. What is SQL? Why do we
Yeah.
need SQL? Do you know what is
Absolutely.
a
Yeah. I
SQL?
mean, I have been using SQL for in my last few projects, and I've kind of came to learn SQL just by using it, not through any course. But yeah, I mean, to be honest, I've seen how powerful it can be. You could have like multiple dimensional data, related with keys, and then you can have stored procedures which will generate tables based on the conditions that you put in. So yeah, it is very powerful, and it has a lot of features that you need to learn. So you could actually like have a full-time career just by being a SQL database expert. But if you don't want to do that, you still can have like basic understanding to sort of get your way around SQL databases. And I think that's one of the most popular databases, isn't it? And it's free to use. It was provided by Microsoft, I think.
No, so
um,
so hang on. So
oh,
here
right,
here
okay.
here's the confusion. So SQL is a database. It's actually not a database, it's a language. It's like a programming
Right.
language. Okay. So the full form of SQL is structured query language. SQL in short, instead of saying SQL, we say SQL. Okay.
Mm-hmm.
Structured query language. So it's a language to query structured data. That's what it is.
Okay.
And a structured data is stored in mostly relational databases. So mostly it's used to query relational databases. And here you have different vendors. So you have
Mm-hmm.
Oracle, and then you have MySQL, Oracle databases, which are private, Microsoft MS SQL, so Microsoft SQL databases. Then you have
Ah,
MySQL, so which is open source. Then you have Postgres SQL. So this is again open source. It is a fork of
right.
MySQL. So MySQL got acquired by Oracle. So the open source community, the one of the founders of MySQL thought, okay, because it's now going to become private, let me source the file, fork the file from it, and then create a new branch, and then create my own new. So that became MariaDB.
Oh, right, okay.
Uh,
I
yeah,
didn't have all
so
of
so
this
you have
knowledge, basically.
MariaDB, you have PostgreSQL, you have Microsoft SQL, you have Oracle SQL or MySQL. So yeah, so you have different types of database from different types of vendors. And what they do is they provide you a database management system, DBMS. How do you manage your data? So you can create your database, right? You can create it in an Excel or a CSV or in one of using one of these tools, but you still need to use a tool to do it. And that's where these systems come. So what we are using in our current project is Microsoft SQL database.
Right, okay. So here's a question. I mean, if I create a database, so
Yes,
if I create a database, there is a database file, right, which
yes,
contains all the data.
yes.
Now, can that database file be then queried by a different tool, like you
So here,
mentioned?
here, here is the thing. If it is open source and it has standardized, I mean, okay, let's forget about open source. If it is a data in a particular format, when you export it, then of course you can import it into another database and then query it. Challenge is most of the database when you export it, it exports it in their proprietary format.
Ah, okay.
If you can export it using some database I'm not aware of. I've not used database to that extent. But if you can export it to a format which is compatible with other database management systems, so it's like
Right.
saying PDF. Can I open PDF in Word, or do I need Acrobat Reader, or can I open PDF in some other tool? So similarly, the database, when you export it, it will have the tables, it will have the columns with the rows, your stored procedure, etc. And if you want to use that in a different system, then that different system should be able to read that file.
Yes.
If you create a file that is not being able to that the other system cannot read, then of course you can't open it, right?
Of course, yeah, yeah. That's what I was wondering. That is it like, all of these providers, are they like kind of, keeping their
I am
proprietary
guessing
format, or is it
they are not, so they will have their own proprietary stuff.
they're not as friendly as
Yes, but importing data is easy. Exporting and then opening it in a different format is difficult. But importing, I think every provider provides the simple option of importing data using CSVs, flat files, or
right,
Excel.
okay.
Excel. So if you have data in rows and columns and you want to quickly upload them rather than typing everything, you can use those files and then store it as a table in your database. And then you can modify everything.
Right, okay. Okay.
Plus the other thing, I think, so database management system allows you to manage the data. But when you talk about managing data, what does it mean? Managing, giving access to different people, the same
Ah, of
data.
course, yeah.
How do you structure it? How do you make it more secure? How do you scale the data? How do you make sure that the backup is taken? So you need to have a system in place, and that's where this DBMS or database management system come in place.
Okay, and this is also another reason what we were talking about earlier. This is another reason to have, you can't, that's one of the reasons why you can't just have one massive
Big
table,
Excel
because you
sheet.
need to give, yeah, you need to give access to particular data to particular,
Exactly.
specialist,
Exactly.
you know, yeah.
So, so,
So
and the way you do it is you provide user permissions. So you will create different users who have different levels of privileges. Some can read data, some can write data, some can create data, some can. So when you say write, it's update. Create is creating something new, and then delete. So I'm just deleting a row of data, a table itself, or just the entire database. So you need
yeah.
to have different privileges, and then that comes up with managing user permissions and roles and etc. So you need to first authenticate a user whether he should be able to come and have access to the data, and then you need to provide what kind of authorization the user has. So what kind of privileges does the user have? So suppose I have authenticated to access the database, but I only have read access, and you have authenticated the database but you have create access, so you can create data, you can read,
Right, right.
create, and update. So you have more authorizations or more privileges than me. So that's one thing. The other thing is taking backups. So in an Excel sheet, you will have to copy one file to another file and then taking worrying about it. But here you can just take a snapshot. So people in the DBMS world, they say taking a snapshot in time. So you take a snapshot at a particular date and time and you store it. And a lot of times, what happens is people take a snapshot, and that's how they replace the data. The entire database is replaced with a single snapshot. So you take the snapshot of the most
Right.
stable version every single day at a particular time, and you store it.
Hmm.
And in case something breaks or something happens, you can restore the data.
Right, okay, okay.
So
Yeah.
when
That's
databases get hacked, you have to think, okay, how would they restore data if someone corrupts it, someone breaks it? They should have a backup somewhere where, or if there is a calamity, earthquake comes, flood comes, the data center is flooded, all the data is gone. If they have a backup, then they can restore the data at least to the latest possible uh, time period. And
right, of course,
that's
yeah.
why a lot of people prefer to store it in the cloud and across multiple data centers.
Okay, now that, yeah, that makes a lot of sense now. Yeah.
So that's just the aspect of this. The other thing is scalability. So as the databases grow, so you'll have more tables, you'll have more columns, you'll have more types of data coming into your system as your system evolves. So then querying that data from the database will again become a big challenge. So then how do you uh, manage that, and that's where DBMS comes.
Right. Okay. Okay. How
So
do you manage it then?
I mean, you have to start scaling up the query. So you will have to do create better indexes and make better queries. So the
Right.
stored
Right.
procedures that you were talking, the stored procedure is nothing but the language to query, right? Because
Yeah.
so I think we didn't talk much about SQL, structured
Mm-hmm.
query language. So it allows you to query the structured data, but how does it allow you? So you use statements like select marks from table table name marks student marks. Okay, so select that
Right.
particular column. The column is nothing but the field name from this table, where the student name is Rinat. So I will
Yeah.
select your marks from a table. Understood? So this is what the statement is telling you.
Yeah. Yeah.
It's and this query
Exactly.
language is actually very common, and people, if you think about it, it's SQL is very common in Jira. If have you used Jira before?
I have. Yeah. Yeah. It's
Jira has
a
its
CMS.
own query language called JQL.
Uh-huh. Okay.
It is nothing but SQL. You select
Right.
something from a table or a column or a row or a uh, issue type. So
Right.
in
Right.
Jira
Yeah. Yeah.
everything is issue,
Yeah.
and
I
then you have
have
different
made
issue
queries
types.
in Jira. Yeah.
So so if you
Okay, I
do
didn't know that was a language. I just thought, okay, let me. I need this. So this is good because the languages are actually not too difficult. It's quite like
very simple, yes,
human languages because you can
exactly.
kind of it's like an English sentence
Exactly.
mostly.
So it makes very easy to query the data from a database. So Jira has lots of issues with different issue types. Now you want to
Mhm.
have query a particular issue with a particular issue type which is most recent, updated by this user, etc. So you use the query language. But Jira, what it does is it gives you, without using the language, it asks you to use a filter. Okay,
Right.
select this
Okay.
filter. So in this filter, if you select, if you check these boxes like in Excel, so you have filters, right? So if you select those particular things, then you will get that data. So, but Jira, you can do advanced search, and that actually uses Jira query language. And this query
Right.
language is actually quite popular, and it's across multiple systems. Jira is one example where you use query language. Databases are one where you use query languages, and then there are other systems which I will mention in the description, where you can use a query language to query the data. But
Right.
now there are some database where you don't use a query language, so they are called NoSQL database.
Okay. How do you query in the how do you retrieve data, particular data
So,
in
so, so first we need to understand the in the structured data, we before we create the data, we define the data, right? So,
yeah?
like you are a UiPath expert, okay? So before
Mm-hmm.
you create your robot, you tell what to expect, whether it's an integer, whether it's a character, whether it's a variable
Yes.
character with integers and characters, whether it's a decimal, etc. So you define what character, and then you also define what is the length of that field, so that
Yes.
you cannot have anything random in that particular thing. So you have validation, right? So you create schemas. So normally in any database, you will have to first create a schema. So what do you expect in the table? You first define
Mm-hmm.
that. So that's a schema. NoSQL is nothing but a no schema. I don't want to define the schema because the data is coming with so many different attributes that I don't know a standard way to define the schema. I don't know what to expect
Okay.
from the data I get, so I cannot define it in advance. And because I can't define it in advance, I cannot use the traditional database. Because traditional database means you have to first define the schema, then create the table, and then put the values.
Right, right, okay.
And in the
But
no,
then how would I retrieve it? It takes, okay, it will take in all the data, but how do I, when I want
so you
particular data
query,
back?
and the query part is again you can use calls. So there are queries, but it's different from the SQL queries. I'm
Right,
not
okay.
exactly sure how do you retrieve the data, but one of the most popular NoSQL databases, MongoDB. It is one of the most popular, and that takes care of this. But in NoSQL, there are different ways you can store the data. You can store it as a JSON object. So
Oh, okay.
we were doing a recent project. We'll not get into too much detail, but you had to interact with a JSON object, and that JSON
Yes.
object had, say, order details. Okay, say you go to a restaurant and you have all the order details. What is the starter? What is the main? What is the dessert? How many people have
Yeah.
ordered, and what is the price of each item, right? And if they have any allergies, and are they any vegetarian, meat eaters, vegan, etc. So all that
Yeah.
information is in one JSON object, and that you get back. Now imagine you have different types of JSON objects, and you can then query those JSON objects. So that's one way of storing the NoSQL data. The other way is key and values. So suppose you have city map information. So you will have, sorry, address information. You have names, city names, you have country names, and you have postcodes. So you can store, okay, all the cities will be stored under city, all the countries will be stored under country, and all the things will be stored under this. So there are key value databases. But this is, you define as it comes. You don't define. And then there is something which is called wide column, I think. Yeah, wide database.
Okay.
I'm not sure the exact name, but that is the most interesting. It is, you have like rows and columns, but now each row can have different columns, number of columns. So say
Oh,
column
right.
A, row A has 10 columns, but row B has 5 columns, and row C has 15 columns.
Okay. So,
So,
so I
so
mean, would you not?
you store the
I mean,
data. Don't ask me. I mean, this is what I know from what I've read, that you can actually store data in this way as also, and it is actually quite interesting, right? You can have one row
yeah.
with 5 columns, one row with 10 columns, and one row with 15 columns in the same table,
Okay. It
and
just
then you
seems
have the
like
graphs where you have the nodes and the connections.
right, right. Okay, okay.
So it's massive. I mean, I can see from your face that it's too much.
No, no, yeah, I was just thinking that, it would be like, as simple as just, the table becoming just bigger to accommodate the row with the biggest column. I mean, it would just be,
But then
whichever
it
row
becomes
has
very
the highest
difficult to
column.
query, right? And it's difficult when you have massive amounts of information. So imagine if Facebook has to track for 1 billion users each like, and each
Of
like
course.
posted by each individual, and then show that like across all their friend list, and also
Yes,
track
yes.
the friends like and show it across to their friends, and you have to track all that information and store it, so you can retrieve it and display it for anyone. So whenever you access Facebook, you get the most up to date information, no matter where you
Right.
have liked the post. And that's the
Yeah,
challenge part.
it's very interesting and mind-boggling. The scale is what makes it, so powerful because, yeah, I mean, you can easily store some data in an Excel file or even CSV, but when it goes to billions of data points, which can easily happen, with
It does
it
happen
doesn't
now,
even
especially with the internet.
Facebook. Yeah, yeah. I mean, with internet, even a moderate-sized business could have billions of data points. Like Facebook is obviously everyone knows. I mean, there are other like Airbnb or even Uber.
LinkedIn,
All of
social networks have
yeah,
very complex connections.
yeah, yeah. And even like even if you think about something like even a smaller company, I can't think of one off the top of my head. But even like say for example, any small company even also have to have like if they have like a 10,000 of user base, that 10,000 user base will have maybe 50 data points, and then that just very quickly exponentially grows into a million data points
Yes.
because so yeah, I mean the power comes when the question is to deal with a massive amount of data, and you also want to visualize it. You want to do analytics because one of the main things to get out of data is to be able to make informed decisions, to
Exactly.
find out
Yes.
find out in relations between those data which are not very um, easy to see, or which you wouldn't think of very easily. I mean, I think one of the examples I can think of is out of a research it was found out that people who, I mean, this I mean, nowadays 95% people use Chrome already,
Yes.
but
Yes.
even like maybe a decade ago in 2005 or 2010, at that time Internet Explorer was still there, had a bit of market share, maybe, I don't know, 20 to 30% or something. But it was found out that people who used Chrome were kind of more successful or takes more initiative in life and that kind of thing. And the now if you now this could seem like a very bizarre relation. Like,
Relation. Yes.
how could it be that whichever application you use has any relation to what kind of person you are in life? that's
True.
that's just like very big. But knowing that data, knowing that insight, now if you go and download Chrome, that's not going to change your personality straight away. So this is why it's important to know what's the causation and what's the correlation between these two data points.
True.
And what was found out is the reason is that when Chrome first came out, people who actually took the initiative and went on looking for a better alternative and then downloaded Chrome. That's why this relation exists, that people who actually took the initiative always looked for newer technologies and then adopted to a better technology. That's why those people have this character trait. If you now think, oh, now I'm going to
I
use
should
Chrome
download
from
Chrome.
now. Yeah, that's not gonna change this correlation. So this is why it's important. I mean, another interesting correlation is most of the Nobel Prize winners like dark chocolates or have more dark chocolates. Now, this is again a very bizarre relation, but you have to also find out. I mean, with databases helps us correlate all of this data and find out what the actual reason is. The actual reason is a lot of Nobel Prize winners are from Switzerland, and dark chocolate is a very popular thing to have in Switzerland. So
Okay.
if it's not in any way related, you're not going to win a Nobel Prize
Nobel
if you
Prize.
start having the dark chocolate. But it's important to understand the correlation and causation, and these kind of things, these kind of revelations, can be possible if you can manage large sets of data. That way, if you manage and visualize these data, then a lot of things become clear, which isn't clear otherwise. I mean, I could go on actually.
Go on. Go
I'll
on. Go
just
on. Give
I'll
me.
go on with the
Give us
last
one last
example.
example.
Yeah. So, um, there is a direct like it was found out that when the ice cream sales increase, the rate of crime also increase. So
Okay.
if you have if the sale of ice cream is increased, the rate of crime, or assault and that kind of crime, is increased. Now, that is a bizarre relationship, but that is
Yeah.
a statistical fact. But why is this a statistical fact? It doesn't mean that selling of ice cream or people buying more ice cream is making them more aggressive. No, it's just that it happens to be both of these things happen in summer.
Yes.
In summer, the weather is hot. People become more hot-headed, become more aggressive, so they're more
Ah.
likely to do something aggressive.
Okay.
But at a completely unrelated way, because it's summer, people also buy more ice cream.
Yes.
So it's there is no causation in here, but it is correlated statistically. So how would you come to this? I mean, if you just had these two data points, you would be like, oh my god, we need to stop all the ice cream sales. But that's not the case, and you could only come to this insight through the visualization or through the insight of large amount of data with different columns.
Exactly.
So this is why database is so important to
But I think what we covered is database, and we need to understand the application.
yeah, the application of database. Sorry, we kind of
And
went off
and
track
uh,
there,
and
but
and you're right. Without the analytics, that data is basically meaningless. If you're
yeah,
not trying to use the data in a meaningful way, then what's the point of storing all the data and categorizing it and then providing read-write permissions and then trying to take a backup? What's the point? There is no point.
yes,
But there are applications where you actually need to do all that, and yes, analytics is one major aspect. So, one of the main applications for databases is for storage of information. a lot of websites have a lot of information and they have similar types of information. Say a product catalog for a website that sells lots of products, say Amazon. Amazon sells a lots
Yeah.
of items and they want to have a product catalog. So rather than creating an HTML page with all the products on each page and then displaying it, it stores a database. Based on what the user wants to search, it then has a stored procedure, as you may call,
Mm-hmm.
or whatever query it has already created. And then, based on the user input, it will retrieve the data from the database and then display it in the format to the user. So that's one
Yeah.
application. So rather than managing all the data in the HTML page, you manage the data in the backend system. So that's why it's mostly part of the backend system. Another application is analytics, as you rightly mentioned. So I have lots and lots of data. I want to
Mm-hmm.
analyze that data. So I first have the data in the raw format, just rows, fields, and columns. Then I have some stored procedure which adds some intelligence. So I want now using the stored procedure, I have all the data, but there is no connection. So I've made the connection using the query language. And then I have, say, out of 1 million rows, I have now 10,000 rows, which are in the with the rows and columns that I want to visualize it in. I retrieve that data and then I visualize it. So data warehouses are very powerful in that aspect. So you have lots and lots of data, and then you categorize them, or you have filters already, or predefined tables, or custom tables, not predefined, custom. So you have modified all the rows and columns. Sorry, you have all the data, and then you have some customized queries, and then you get the data, and then you visualize the data. And because you have already queried it, you don't have to query the database, categorize it, and then display it. Because you already have the query ready, the data is available, so you just use that. So it is fast querying. It's like cache.
Right,
So,
right, right.
so in caching, what happens is you try to retrieve the data, but if the data has already been retrieved, you go first to the cache, and then you go to the main server to retrieve the data. So similarly, you
Right.
will have already a query that you have already created, which has got the table, and now you just use the table rather than querying the database again, writing the query, etc. So you write predefined queries. So think of it like this. If a company like Vodafone wants to sell a lot of mobile plans, SIM plans, SIM only plans,
Mm-hmm.
and they every month or every quarter they come up with new plans. But how do they come up with new plans, and how do they make sure that those plans will sell? So they need to
Mm-hmm.
do some analytics on what plans are currently being sold, how people are using those plans, how people are spending using our network, where people are actually spending more money. So all that analytics has to be done, and that you cannot do without big data warehouses, which already says, okay, this is the plan, these are the customers, this is how the bills are produced, this is how much data they consume, this are how many calls, SMSs they send, etc., etc. And they can then say, okay, we will create a plan because based on this data, we can see this is how people are using our services. So if we create this plan, we are assuming that people will still continue to use those services, but we can charge them a bit more or less.
Right,
If we
right,
charge
right.
less, then more customers will join us. If we charge more, we'll get more revenue, but some customers will leave us, right? So that's one aspect. The other is, I mean, just prediction.
Mm-hmm.
So
Oh, yes.
so we don't think about we normally talk about technology from a IT perspective, but think about all the scientific database, weather monitoring, earth monitoring,
Mm-hmm.
remote sensing.
Yes.
They are collecting temperature, pressure, humidity information every second at every
Mm-hmm.
possible location in the world, and they are
Mm-hmm.
combining all that information and then making a prediction as to what the weather will be like tomorrow. So imagine how much data they will be generating over a period of a single
Yes.
day, and then how much data do they need in order to make an accurate prediction? Even now they cannot make any prediction accurately. I mean, that's the challenge. So
Forecasting is a big.
it's a big thing,
Yeah.
forecasting, and lot of databases and analytics is actually to make predictions. What
Mm-hmm.
will customer buy? What will the users like more? What should I sell them more? So
Yeah.
and And a lot of analytics like Google Ads and other analytics. What are people
Oh
actually
yes.
clicking? What are people actually downloading? What are people actually searching for? That information
Yeah.
is very powerful. And that's why
Mhm.
you have this privacy of data. What I search, what I type, what I look for is my information and it should be private. I don't want the whole world to know that I'm searching for a toothbrush
Yeah.
or
Yeah.
a particular brand of toothpaste because then they can target me with an ad for that toothpaste. So data
Yeah.
privacy. So you have data privacy, data storage, lots of data security. All these
Of
aspects come.
course.
I mean, of course,
Yeah.
everything is related to the database itself where the data is stored. So anywhere where a data is stored, we call it as a database.
Yeah. Yeah. Yeah, no, I mean, I think we covered a lot of aspect of database. Anything else you want to add at the end?
Future, what the future
Mm.
looks like for databases and where the technology is heading. Automation. I mean, you work in UiPath robots, right? And your robots interact with databases, and they can do it, which a normal human doesn't have to, right? So you have to
Yeah.
query a database repeatedly. So you create a robot, and it does the work for you. Now imagine in the future where you don't need these database managers.
Mm-hmm.
All the administrative work you can actually automate. So there is this concept of self-driving database.
Absolutely, and there could be another aspect in future as well with the integration of AI, because right now you have to look for correlations. You know, you
Yes,
have to look at different data points and visualize and find out, oh, is this related to that or not? But that could be quite cumbersome, and you might not see and something. But an
exactly.
AI could be designed to pinpoint and identify where there is correlation that we never even thought of. Maybe something very unrelated, but with that you can kind of come to an actual statistically significant decision making. So
Absolutely.
yeah, so it could go so many ways in future, and
Definitely. I mean, if you look at machine learning, most of them are being driven by large data sets, right?
absolutely, yeah,
So,
yeah,
so AI can actually look, as you rightly said, correlate what we humans might miss, and then come out with some inference that might be very insightful, that humans would have never
yes,
thought
yeah.
of, because we cannot analyze that big much information.
Absolutely, absolutely, and yeah. So future is a very I definitely will watch this space, and how data sort of evolves and management of data kind of helps us as humans to progress. One other thing I want to add as well. I mean, obviously, database might seem like an ancient topic. I mean, we've been dealing with databases as long as there were computers, but what I want to emphasize is that in recent days data science has become a very powerful thing to a skill to have. um, Data science and big data. So machine learning, as you mentioned, artificial intelligence also relies on being trained on a massive large amount of data, and then also utilize a large again a large database of um, data to sort of operate as well.
Yes.
So what I want to basically emphasize on that, even though database might sound like a old topic, and you might want to move on to database, data science or big data AI, but we have to remember that we always need to manage all of this data, index and store all of these data in a meaningful way so it's easily retrievable and really so it's usable in however way you want to. So database is was important yesterday, is very important today, and will remain important to support all the future technologies that we're gonna build and create. So it is definitely something to definitely something to learn about, and at least have a basic understanding, so you can
Yes.
do all the other crazy and cool things when you have the knowledge of database management.
I think yes, you have nailed it. Yes, because databases are key for everything. They have evolved, but they are still relevant. So from normal
Yes.
relational databases, we have now gone to NoSQL databases, graph databases, etc. But there is still a database We are creating so much
Absolutely.
data that it's very easy to now make predictions about our behavior,
Yes.
shopping behavior, watching behavior, viewing behavior, etc. So yes, databases will always remain relevant. So it's actually important to understand the fundamentals. I think most of the topics that we have covered, what we have covered is the fundamentals, like okay, what it is actually doing. Once we know what is the need of something, then we can identify tools to play with. So it doesn't matter what database you
Yeah.
use, it matters that you know what a database is. Then you can use any tool in the world you want.
Absolutely. Absolutely. Great. So yeah, this has been a good talk. I've learned a lot and also enjoyed talking about all the things that I know. So I don't have anything else to add to this topic.
Same here, Renat. I think it was quite insightful to talk, because I think when you explain a concept and when you are trying to articulate it to someone, you actually learn more in the process.
Hmm.
Talking to you, yes, I've also learned a bit today. And I hope the people who are either watching this video or listening to us on a podcast have actually gained some knowledge about what databases are, why we need them, etc. And yeah, please do like, share, and subscribe to our channel, and post your comments about what you like, topics that you want us to cover. And if anyone wants to come as a guest on our show, please let us know. We always provide our contact information in the description, so please feel free to contact us and let us know. So, thank you so much again for watching and listening.
Great. Thanks, guys.